Okay, so today I'm going to talk about the biological foundation for ego and everything what is related to that, why it appeared, and what to do with it. Yeah, so from the very beginning, when this like soup was on a planet where different molecules were just swimming in it, and then they, I don't know, does it look like molecule? Whatever. Then they got together, got a cluster of molecules, and then this cluster became stable, and then this cluster, for some unknown reason, decided to replicate, and then we get like plenty of clusters of different molecules. However, the actual goal of, for example, bacteria, so single cell organism, right? So all it does is like, let's say that's the organism. All it does, it takes care about the energy intake, and making sure the uh, membrane of the cell is intact and it's like soft. There are no holes and so on and so forth. And also the third part, like okay, the membrane, and the third one is conditions, or we can say stimuli, because for example, if it's too salty, then bacteria has to swim away. If it's like too hot or too cold as well, the same story, right? Yeah, so basically, for bacteria, there is a quite selfish goal, is to stay alive and replicate. Bacteria doesn't really care about anything else, and if they live together, well, it's just a coincidence, because if conditions are changing, then bacteria either die or they go in a slow-mo mode and don't eat a lot and just wait until conditions become better again. So that's that. And because uh, a world of limited resources, uh, so billion years, that strategy was quite successful, like taking care about themselves, uh, and uh, moreover, then bacteria became amoebas, whatever, with nuclei inside, right? Then the next stage was colonies. Again, the cells there they were more independent from each other, but because they stick to each other, they they relied on each other in some way, but in the end of the day, they were quite independent. If a piece of a colony was falling off of a main one, a new colony emerged, and that was the process. But in a way, cells behave quite individualistically, right? So after that, let's say colonies, then plants, plants and plants can put fungus there, fungus, and animals, right? Or yeah, let's say animals like worms, for example, and so on, right? So as well, a plant also doesn't really care about its fellows next to them. So, for example, if you've got a pine and it it doesn't really, it can't really do anything about a pine next to it. Uh, they just like fight for resources between each other, and weak one dies. But at least we don't know. Either they are communicating or help each other, right? So that's about plants and the worms. Uh, worms are quite selfish as well. Selfish. So what that means is their goal is to survive and replicate, right? So those strategies are in their genes. So, and the way it works with, like, let's say, nervous system, or even without it, is when you've got your model or your animal model, whatever, it gets some stimuli from the outer world, uh, and it got the reaction, and reaction is the towards action towards survival or replication, right? uh, so, uh, so even when organisms stopped being cellular ones, like, and became multicell organisms, the selfish stuff didn't go away. However, the cells themselves, they become less selfish, right? So they've lost piece of their ego, so to speak, right? Because, like, if you've got an organism, let's say a worm, uh, flat worm, right? It's got eyes, it's got, like, I don't know, some guts, a bit of muscles, a bit of nervous cells, right? So those cells have function, and different cells do different things, and some of them are taking a bit more work, some of them are lazy, some of them are immune cells which are dying because of that, and trying to save the organism itself. So entire organism is remaining selfish, while cells uh, start losing that ability or quality, whatever. Start losing selfishness, right? Whatever. Okay, so, and that was quite a long time, and I might suspect that yeah, we don't go to yeah, primates. It's too fast. But let's say we look at at the better version of social ego, and that's fish, because, like, fish is quite old. Uh, so we've got worms, and then we call fish, right? So there were flatworms, then were the tube worms, and then fish, let's say, right? So a fish is quite a long time, especially sharks, for example. Uh, so fish are quite old features, quite old creatures, right? So and then so their discovery was that the fish hanging out together, uh, they raise their chances for survival, and that's quite interesting, right? So shoaling, it just like plenty of fish in the same spot, right? And they are not organized. They are not looking at each other, or maybe looking for mating purposes. What means like replication is in place, right? But they are not doing particular things all together, right? While when you've got a school of fish, they are synchronized, and the way it's done is that if a predator, a shark for example, right, with teeth, is trying to catch, because their movements are highly synchronized, shark is getting lost and can't chase the prey. But what we are interested in is uh, that the let's say it's a single fish here and a single fish there, and they've got their brains and they're observing what happens around them, right? They're, that one looking at that one and that one looking at that one, let's say, or they've got, I don't know, through some other senses, understanding what happens. So when this fish is moving away at a fast pace, that one's got that stimuli there, alright, and it's getting a motivation to do exactly the same. And that motivation, well, I can't say it's a motivation per se, but it's a reflex. But for the uh, explanation, say, let's say it's got a motivation to do something, and it does something what it didn't even think about like second before. And but it's a first version of uh, pro-social behavior, because if it doesn't do that, that fish doesn't do that, so it dies, right, with a high probability. It dies with a high probability, or entire school is under the threat, right? So genetically, in the brain of that fish, there are particular areas which are responsible for, let's say, pro-social behavior, right? Behavior. Because a fish is moving with its brain. It doesn't move by itself, like, do you know what I mean? Because the act of moving requires information, uh, model inference in the brain, and action, moving muscles. Right, we don't know. Maybe that particular fish is getting excited, or it feels fear, or combination of those emotions. But we can observe only the consequence of the process of the consequences of the process of interaction with the outer world and with its friends. Okay, then we go, right, hang on, yeah, like that. Okay, so some fish, like cleaner fish, right? They've got a reputation. That's also interesting thing in it. If they cheat by biting client fish instead of cleaning, other fish notice it and just avoid them, and they stop being part of a crew, and that's also dangerous for them. So they have to be around themselves. So what I'm interested in is when other members of the group notice that the fish is biting a client, then what they feel. Do they have feeling? That's interesting, isn't it? Like, I feel disgust. Like, how can you do that? This is so bad. Or they scared. Oh shit! What is it doing? Like, he's just yeah, he's doing a catastrophe for all of us, and so on and so forth. So it would be quite interesting to know the what fish agent um, experiencing inside of the brain, because they see something, they feel something, they otherwise they wouldn't act, would they? Right. So then we go to reptiles. So fish once on the surface and become reptiles. Well, part like 1 foot, 1 foot, or one leg on a sand and another leg in the water. Right. So what is interesting here? Um, amphibians Amphibians are low energy, yeah, of course, because they don't heat their blood. Uh, so the frog being selfish is in. Aha. So yeah. So because selfish for a frog is just a natural order of things, but lizards, they are also cold-blooded. They can have a nuclear family, that's interesting, or groups, and protect their young. So again, when we observe the action of the family, of the lizard family, what does it mean to us? It means that lizard does spend an attention, which is resource, and time, which is resource, for future good, for kids, and that means they increase their chances of their survival, and that means that the action is supposed to have a motivation. So if lizard sees another lizard and they fall in love, and that means they feel something, right? Because otherwise they would just leave, like, leave me alone. I don't see any difference being with you or without you. But this is the social ego, right? The family ego. So two lizards, lizard one and lizard two, connected together, and they are making a bond, and they have a common goal, or two common goals: survival and replication. Replication, right? And they love each other. They feel like they have to stick to each other. And maybe when one lizard goes to hunt, lizard two is missing lizard one, and vice versa. And so what that means for us, they've got emotions, they've got feelings, and again, because we can observe by the consequences of their motivation, right? Again, so we've got stimuli there. Stimuli, lizard sees, lizard 2 sees lizard 1. That's the stimuli, goes into the brain. Brain creates a feeling. Brain creates a feeling, and that feeling creates a motivation, and the motivation is becoming an action. An action is just staying action is just a way of maintaining equilibrium, right, or status quo for that matter. So again, important part here is that even fish uh, is able to be less selfish than just the default organism, right? Default settings, right? So, and again, if we are talking about how this is emerged, so how I think it was. So let's say generation one, right? So we've got like bunch of lizards, which are able to make families. So let's say here is a quantity, and here is the strength of a family, and we've got normal distribution. So those ones here, they didn't form family at all, right? They did not. Those ones stick to each other, and can't really leave each other alone. And those ones were sort of normal, and that generation one. So uh, those ones are dead. Those ones are also dead because those ones wasted resources sticking each other. Those ones didn't bother making sure that it's gonna be sort of profitable, and those ones survived, right? And those ones here had an advantage, and that generation won. So exactly the same thing happened the next generation here. So all those offsprings got there, and they made another normal distribution. And again, the same thing repeated. So that's generation two. Again, those ones dead, those ones dead, those ones remained because they were having an advantage here. Uh, right, and this cycle repeated a lot of times. So I don't know. I don't know. Let's ask AI. So for example, how many generations of lizards passed since their appearance, roughly? Okay. So what I want to know now is uh, how many generations this iteration happened. Okay. So what is it saying to us? Roughly, for humans, 100 million generations, right? Yeah. So 100 million generations. What we had there was 100 million of those iterations. So it's something like 10, 6. That's 1 million. So another 3, 9. Yeah. N times in power of 9, 10 in power of 9, a number of generations this process happened with normal distribution, and hence we have those not really selfish lizards by now, right? So I can't say those prehistorical lizards were the same as modern ones, because there are 10 in the power of 9 generations of the selection, but in evolution sometimes good solutions can go in parallel. So I can speculate that like fish and uh, reptiles have parallel evolution with so-called social behavior, or the social behavior appeared at the same time. That's the matter of the discussion and the research, because if the same neural chemicals are working for both of them, we could potentially assume that it was a common ancestor who wasn't that selfish. Otherwise, we could say, all right, if in that animal that neurotransmitter is responsible for social behavior, and in that one another one. Right, so that's that. Right, let me move forward. Okay. So the brain is trying to maximize success score, right? And this is our, if we get back to trading, so we've got our capital, we've got our possibilities, and we put this capital into a function which is accepting capital. Inside of our function we have calculations, and outside of the function what we want to get is delta t lim 0. So we don't want to waste time, we want to return on investment straight away, as short as possible. Okay, a bit smaller like that. Right, then we want delta dollars endless, and we want our, what else we've got, right, yeah, that's enough. Yeah, and risk supposed to be also 0. We don't want to risk anything. How does it translate in our this thing there? So basically survival is a function where we put our resources, and outside we want to get the survival, which is limited to infinity. We want to live forever, our offsprings, and we want to replicate, right? Replication also, that's the limit plus infinity. We want to replicate indefinitely, and we have some constraints. And that function there, prosocial behavior, is just creating, the function is creating those constraints, right? So constraints are, there's an individual success and there's a social success, right? So we could rise above a group, for example, and this would potentially decrease our survival and other ways of successes, because if we are not acting in harmony with the group, the group group's chances of survival decrease, right? So what I mean is there is an individual, right? An individual is the one of other individuals in a group, right? So if group survives, then individual survives. If group dies, then individual dies, right? So what that means is the complexity of the function drastically increases, because when you've got two lizards, right, they have to take care about themselves and that's it, and maybe their what eggs and what comes out of eggs. However, if you've got a primate group, then there's a problem, right? So uh, so you have to make sure that others doing at least okay, because if they start being sick, if they start being Okay, so what we don't want, right? Let's say we are super successful uh, as a member of the group. So, in order to increase group survival, what we want that our fellows are healthy. Second, we want to make sure our fellows are able to work for the good of the group, right? Because if they are not, then we are only the ones who's gonna work, and group dies, right? Because it's gonna be not enough resources. So I'm trying to say here is, so if before it was a selfish bacteria which was just replicating and eating each other's food, then multi-cell organism is the next stage when different cells via genetic code. This is the worm, and here are the individual cells in it, and via genetic code they behave in a particular way that entire worm survives, and they've got their roles, they know what to do, and so on and so forth. So now this role is taken by human group. So we've got human group, and this human group has different members of the group, and those members are doing particular things, and the entire group survives. And things are becoming more rough and complicated when you've got your competitor group over there and they don't really like you, and they start fighting with you, and you have to respond, and then the pressure increases, and then you have to know more professions, you have to know how to fight, you have to know how to, survive, live under pressure, and so on and so forth. Plenty of things. Now, so what we've got in the end, so we've got the constant calculation what to do, right? So we've got constant calculation in our brain. Do I have to stick to my ego aesthetic needs, right? Yeah. Do I want some drugs? Do I want some uh, other pleasures and so on? Do I want to stick to leisure, right? Or I have to sacrifice myself, sacrifice uh, for the group. And now we've got a few different scenarios, right? So we've got a few different scenarios. We've got hero, uh, and hero is just a person who complete, completely neglects personal needs, personal needs, right? So hero, and then we've got villain. This is the opposite one. Uh, it doesn't villain doesn't even think about own pleasure, right? It does think about how to exploit the group, and that's the devil, right? That's the potential uh, harm for entire I don't know, tribe. And if a villain is quite creative and they can do a lot of bad things, so they can exploit entire humanity, right? That's the optimal villain who is thinking how to achieve own personal selfish goals, and uh, and the humanity is gonna pay for that. Humanity is gonna pay for that. Right. Yeah, and in the end, there is a win-win. Uh, I don't know how archetypical that one is. Win-win auxiliary group. The gold standard, right? So what that means is, and why I like this third one is, it's the uh, member of the group, member of the group, who's got skills which are needed by other members of society, and they reward for that, right? Members of the group, and they reward them for that, right? With money, for example. So, so what happens here is the formula is simple, right? You've got skills, you can do something which other people find useful for themselves, and you practice and doing that, and everyone wins. Then you don't sacrifice yourself too much, you sacrifice just about enough that it helps others, but you don't kill yourself, right? You don't kill yourself at work and stuff like that. So, and those functions are somewhat dynamic because in one situation, hero is absolutely necessary. In some situations, you have to be a bit of villain, for example, to your enemies who are not really who are hostile to you, and win-win. So again, that's complicated thing, complicated part. But um, all of them are archetypical roles, so to speak. So what we've got further, let me have a look. Ego feels heavy. Let's have a look at that one there. Uh, right. Mm. Yeah, I switched that. We've counted millions here, right? Yeah, good. Okay, moving forward. Moving forward. So why ego feels heavy? Uh, so so the problem is the legacy, right? The problem is the legacy because the mathematics of the function are quite complicated uh, because you are always have to calculate whether you spend your resources wisely, and the the at well so so it's hard to calculate when it's good for yourself, but it's hard to understand maybe that goodness for yourself harms others in a way that in the end it's gonna be even bad for yourself as well. So for example, the case is you live in a town and you want to be the super rich person in that town, and you start whatever enterprise you start, and then you drain all the money from all other citizens of that town, and you've got all the money, but not much you can do with it because others don't have it. So you just with your money. It's the same thing like Bitcoin, right? So while Bitcoin is evenly spread among traders, uh, it sort of makes sense to keep it and work towards it. But if all Bitcoins are in single pair of hands, then just what's the point of Bitcoin if nobody else can use it? And then if nobody else can use it, that means nobody can trade it and price goes to zero, right? So it works only, uh, this currency works only when there are other members who could participate in exchange of that currency. And the same is with actions, our actions. So if somebody wants to become a hero and does something really, really outstanding, but there are nobody to praise it, so it kind of useless, especially if that hero spends their life for that. So it just sounds like a life wasted. Anyway, the main goal of this little stream was to get rough understanding that what we've got in our brain is complicated mathematical function which supposed to calculate a easy good for ego, for yourself, or we have to give up ego and go to social good, right? And the problem here is that ego part is very old. Despite we have this like fish evidence, lizard evidence, birds evidence, and so on and so forth, ego remains quite heavy on uh, quite heavy pressure on our decisions, right? Decisions. So, because like out of the talk, you could get the impression that good social stuff is uh, dominating, but it's not. Ego is dominating. Ego is dominating, and social behavior is the deviation. Deviation, despite it's quite common, right? And interesting part there is when a brain is in the state of when brain has a deficit result of the resources, deficit, when brain has deficit, like it didn't sleep enough, it didn't eat enough, it didn't whatever, it's overheated, then ego is rising because the primordial functions are more important, such as survival. Survival is more important and it has dominance, and the pro-social uh, is much more complicated during those stages. While if brain is happy, it's much easier to go pro-social, because you don't have to think a lot of your own needs and all own pains and so on and so forth. So right, so this is the introduction to ego and when and why it appeared. Right? I would say it's like that. So if lizards, fish, horses, and so on, they have signs of social behavior, they probably do not go in hero mode that often as humans, and that's gonna be the next video, I suppose. So that's it for now. Thank you for your attention, and I talk to you next time, or it's gonna be a book.